For today's class, so today is supposedly to be online, and next week is offline. But since my schedule, I think in around November 26, 27, I will be outside of Taiwan for a while. I think for just 3-4 days. So it will affect some schedule as well. So the basic math and the I think calculus. Yeah, I think calculus, but I'm not sure calculus. But I already prepare all the materials for your class, so I think it should be okay. So we still have our schedule, and for our class for this basic math, my plan is to finish off all the left part, the trigonometry by today. And next week, it's just like slide chapters, slide sections like a polar coordinates, okay, maybe sequence and series, and so on and so forth. And then maybe in the last 3 weeks in month of December, I would like to make a project with you. So we will have some topics. And then you guys need to maybe forming a group. Maybe I will make some random selections between Taiwanese student and then international student. They will be mixed up together, so you can have more discussion. Okay. The topics is about basic math. Okay. I will give you some highlight what kind of topics that you can discuss, and then. I think I need to count first how many of you, maybe one group, maybe can be 5 or maybe 5, maximum maybe 5 students, and you will need to present what your group has discussed. The presentation could be in any content. Okay, so it's not necessarily needs to like a classic presentation. You present and blah blah blah. You could have maybe build something, and maybe you need to recreate something digitally. That's up to you. Okay? Up to you. And you could also, instead of doing some classical presentation like that, you could make a video. Maybe you could put something. Maybe someone is good for editing video. Maybe he has some good work for animations. You could do that all as well. Okay, but the topic will be around basic math, okay? Especially the topics that not really in our class. Like maybe we just slightly talk about it and maybe just skip some process, and maybe you want to elaborate that. Okay, later we can have more details. I will make, I think, one additional video about that project. Okay, I will also maybe giving you some highlight from, I think, previous year students. Because previous year, we only have, I think, only 12 or 13 students in the class. So the project is one by one. But now, since we have so many students in class, we will have a group. And I hope, because of this group, you can have maybe have a better results, okay, compared to the previous year. Okay. Okay, so yeah, that's it for just additional information regarding our schedule. Okay, our schedule in class. Okay, so I think last time we have this. I prepared some videos for the. I believe this is what we have. Okay, so we have the summation. For cosine, and then s minus 3, s plus 3, and then also for sine as well here. Okay. For sine as well, and then also for we can using it for some applications. Okay, let me move into the another topics. Continuation from the previous subject. So the previous one is stating the s plus t, right? If s is equal t, let's say it's going to be x plus x. Hi. Then this will be cosine x minus sine x, sine x. And this will turns out to be cos squared x sine squared x. Okay, and this is a double angle formula that is really nice, really useful, not only for this course, for basic math, but also for your calculus, for your engineering of math, and maybe for all trigonometric related course. Okay, so this will be a double angle formula. I'll just write a double angle like that. And the same thing with the sine. So we'll have also sine. Or maybe let me finish the cosine first. We can rewrite this cosine in many ways according to what identity you want to replace. For example, we have the identity for the basic one is sine squared x, or maybe let me write maybe right here, sine squared x plus cosine squared x is equal 1. Okay, this is really basic. Okay. So we could exchange either cosine squared or sine squared with this basic identity. So we could exchange the cos squared with 1 minus sine squared, or we could change the sine squared with 1 minus cosine squared. It depends on which one you prefer, or which one we are going to simplify. So for example, we could try this and then exchange the cosine squared, become 1 minus sine squared, and then it's become another minus sine squared, and we have 1 minus 2 sine squared x. Okay. The same way, we could have the cosine squared x and then exchange the sine with 1 minus cosine squared x, and it's resulting the 2 cosine squared x minus 1. Okay, these two identities really useful. Okay, you will use this double angle formula a lot in calculus, especially when you learn the integral. It will be really important. Okay. And then for sine 2x, same thing, x plus x, and then you will have sine x cos x twice multiplied by 2. Okay, like that. And then the same thing, if we have a tangent to x, but tangent is not really often, but we can also try. We could verify through the sine to x divided by cosine to x, and then we could replace with either this double angle formula, and we could write down this tangent as 2 tangent x divide 1 minus tangent squared x. Okay. You could try defining this sine to x with cosine to x. Okay, let me give you example. So if cosine x is equal to negative 2 over 3, x is in quadrant 2, find cosine 2x and sine 2x. Okay, now there are some terms that we need to clarify and confirm. We have the quadrant, okay, and then the cosine x is negative. Okay, so as I mentioned, I think in the early video, I think last week's video or maybe last 2 weeks also, I think I mentioned the quadrant. The quadrant means the positions in your axis. If you remember, the quadrant is like this. Okay. We start from this axis and we start counterclockwise. If we want to add some angle, some radians, we start from here and then we go here. It's pi over 2, pi, 3 over 2 pi, and then back to original, it's 2 pi. So one circle, one full circle, 2 pi radian, right? And we say that this is 1, 2, 3, 4, right? And as I also already mentioned, okay, we could retrace how to convert the xy into the cosine and sine, right? If you remember that. So the first quadrant, all sine, cosine, and also tangent, they are all positive. Or maybe, let's just say sine and cosine. Tangent is just the result of sine or cosine. So this is sine, cosine is positive. Okay. And then move to quadrant 2. Sine is positive and cosine is negative, which resulting the tangent is negative. The third quadrant, sine is negative, cosine is negative, and tangent becomes positive. And in the fourth quadrant, the sine is negative, cosine is positive, and so the tangent will be negative. I think to help you observe this or, okay, I know that we have limited capacity in our brain, right? So let me just clarify. So the first quadrant is easy, it's all positive. So you need to remember which one is positive. It's I think very little memory you need. Okay. So first quadrant, all positive. The second quadrant, sine, positive. The third, tangent, positive. Fourth, cosine, positive. All is negative. Okay, I think that is better way to memorize if you want to memorize. Okay, so it says that okay, so the second quadrant, x is in the quadrant 2, cosine x is negative, so of course it's quadrant 2. So we know the sine should be positive, okay? The tangent is negative. So first we could write maybe, because it's asking the cosine to x, so we could write, because we know the cosine x, so let's say we are going to take this into cosine squared x and then minus 1. So let's say we have 2 and then negative 2 over 3 and then take the squared and then minus 1. So it's 4 over 9, 8 over 9 minus 1. So 8 over 9 minus 1, it's supposed to be negative 1 over 9. The second question is sine to x. Okay, because sine to x, it has sine x inside, so we need to confirm the sine x. So finding the sine x, can be done by just taking the 1 minus the cosine squared x. It's supposed to have plus minus, but I know that this will be positive, so we can ignore the negative. Okay. So we write here 1 minus 2/3 squared. So we have what? 4/9, 5/9, right? So 1/3 square root of 5. So sine 2x will be 2 sine x cosine x. So 2 and multiply with negative. Or let me write with bracket. So negative 4 square root of 5/9. And notice that the quadrant, this 4 quadrants, is also represents the angle. Okay. If maybe the angle, if we say acute angle, then it is going to be from 0 to pi/2. Okay, very sharp angle. Right? And if you have the obtuse angle, which means it's greater than pi/2, then probably it could be 2, it could be 3, it could be 4. Okay? It depends on the case, but I believe it should be 2 or 3. Okay. Okay, since we have the double angle, we could also try to maybe formalize the triple angle if we have the triple angle. So like for example, we have the cosine 3x like this. So this 3x, we could imagine 3x is from 2x and x, okay? Oh. Okay. So cosine 3x, we could write cosine 2x plus x, okay? And we could write down cosine 2x, and then cosine x, and then minus sine 2x sine x. And then try our best to solve this. Okay, since we have cosine x here, so let's try to formalize this cosine 2x, transform into the cosine squared. So let's go transform this, and then let's say we have 2 sine squared x cos x, right? Because of this sine 2x is 2 sine x cos x. Okay. Okay, I think we can expand, multiply, minus cos x minus 2 sine squared x cos x. Or I think we can exchange the sine squared with 1 minus cosine squared x. And we could have 4 cosine cube x minus 3 cosine x. Okay, this is cosine 3x. Well, not really necessary to be memorized, I think. Okay, now because we know how to take the double angle formula, okay, now the next thing we can do is we can reverse the double angle and we can build the half angle. So basically this is, let me write, like from the cosine 2x, we could have the 2 cosine squared x minus 1, or we could have 1 minus 2 sine squared x, right? Well, we could rewrite this in terms of the sine squared x and cosine squared x. So we could write from the cosine squared x is equal 1 plus cosine 2x divided by 2. And then sine squared x, we could write 1 minus cosine 2x over 2. Okay. And then within this, we can also rewrite the tangent squared x. We can divide the sine squared with cosine squared. And this will be 1 minus cosine 2x divided by 1 plus cosine 2x as well. Okay. It's nothing new. This is just rewrite how we can rewrite the double angle formula, and then we can make up the half angle. We can lower our powers. And we can also rewrite this and write down the sine we say this is u over 2, that we exchange x with u over 2, and this will be equaling to plus minus 1 minus cosine x, okay, or u in our case here. This is actually the same thing, okay? This is actually the same thing, but we can rewrite this in more general way. So I'm writing plus minus because it will depend on the quadrant also. You can have negative or you can have a positive. Or we can write sine u over 1 plus cosine u. Okay, this is actually the same thing with our approach before. We could take the square root, okay, just to take the sine x. And this is just to show you that it has 2x here. It has x, right? It's the same thing here. If this is u, then this will be u over 2. It's the same thing. Okay, it's just a little bit different or to write and to take terms, but actually they are the same thing. And especially for the tangent, you will see that it can be sine here or sine here. It depends on the forms. It's actually from here. If you can imagine, if we multiply with the 1 minus cosine, 1 minus cosine, or 1 plus cosine, 1 plus cosine, one part of that will be sine. Because if we have 1 minus sine squared, or 1 minus cosine squared, it will become sine squared, okay, which we have here, sine or here. Okay. So if we are asked to find the for example, without using any calculators, if you are going to find sine 22.5, so we could take this and rewrite that this is also, we could write sine 45/2, okay? And then we can rewrite the sine. Since it's a first quadrant, so it's supposed to be positive. So 1 minus cosine 45 divided by 2. And then I think you can finish off this part. So 1 minus square root of 2 over 2 over 2. And you could write this become 2 minus square root of 2, and then becomes 4 here. So we have half, and then square root 2 square minus square root 2. Like maybe you can also imagine if you have sine 15. You could do the same thing using the 30 divided by 2. And then just plug in the same with the same method. Okay. Okay. Okay, so the important thing is leave the quadrants aside from some formulations. Okay. I think double angle, if you know the basic one, the double angle one, this part, the half angle, will be following up the double angle. It's supposed to be. All right. Now, if we have sine, and then we have 2 cosine inverse x. Okay. If you want to rewrite this, write in algebraic expression. Okay. I think some of you are already familiar with this. So let me just take this into because something here, the cosine inverse is supposed to be some angle. So let this cosine inverse become some theta, like that. Okay. Now we could write sine to theta like that. Or maybe before we write the sine, maybe we could discuss the inverse trigonometric first. So let's draw a triangle as usual. Okay. Now x is equal to cosine theta, right? So we could define our theta is here, and x cosine is this x, and then 1 will be here, right? Okay. And then the rest, the other side is 1 minus x squared and take square root. Okay. Okay, so whenever you have an inverse trigonometry, always remember that this inverse trigonometry is an angle. So we could maybe take that into our angle, or maybe another variable as well. Okay. And I believe this method will be, I think, still necessarily true for, well, at least for your calculus. At least for your calculus. I couldn't think any subject okay, that may be calculus. Okay. Now, to write the component, we could take this sine as sine 2 theta, right? So we could write sine theta cosine theta. And how do we get the sine and cosine? We could get the sine and cosine through this triangle. So the cosine will be x, right? And sine theta will be this side, square root of 1 minus x squared divided by 1. Okay, so that will be our algebraic expressions for the sine 2 theta, or sine of 2 cosine inverse x. So we could write this into 2x and then 1 minus x squared. This is the algebraic expressions. Okay, for basic math, we just stop here. We could solve the algebraic expressions. However, for your calculus, maybe you need to derive, okay, and then you need to follow up with some other questions. Okay, the next part is we call the product sum formula. Okay, how do we get through this formula? We could write, first is from the sign. Remember that if we have u plus v or a plus b or maybe x plus y, we will have sine and then cosine v, and then the sign is the same, plus cosine u sine v, right? If we have sine u minus v, we will have sine u cosine v minus cosine u sine v. Okay, if we add these two, we will have this disappear, right? We can cancel this two. Okay, now we could write sine u plus v plus sine u minus v is equal 2 sine u cosine v. Okay, so we could write sine cosine becomes this sum. So this is the product, this is the sum. Okay, sum means we have something plus something, it's called the sum. Product, we multiply two components. We call it product. Okay, we call it product. So this is product, this is sum. So we could write sine u cosine v is equal half, okay, half of sine u plus v plus sine u minus v. we minus this, then we are going to cancel this part, and we can write the cosine u sine phi. So we can write cosine u sine phi with the same structure, similar way, similar method. So cosine u sine phi, this will be half sine u plus phi, but now it's not plus, it's minus because we subtract both of them. Okay. And then what else should we have? We have cosine, cosine, and sine, sine. We could get that from the cosine u plus phi, cosine u minus phi. Okay? So we could do the same method. We plus, we minus, we add, we subtract, and we could rewrite the cosine u sine cosine u cosine phi is equal half cosine u plus phi plus cosine u minus phi. And then the last one, sine u sine phi, this will be half. To make it clear, we are going to write cosine. This part is u minus phi minus cosine u plus phi. You will notice why this happens, because when we have the cosine u plus phi and cosine u minus phi, we have cosine u cosine phi. When it's plus, it's being minus, and when we have a minus, it's being plus at the sum. Okay? You can check the previous pages. Okay, if you take notes on last week, you know what I mean. Do we need to take a break, or we could continue and maybe finish off early? That way. Before this course, do you have any other course? I forgot. Quiz. Okay. How many hours?
No, it's not a quiz.
Oh, quiz?
It's a quiz. Oh, everyone.
So everyone has the same result, or the same fate? Okay. Okay. Okay, we can continue. Okay, we can continue, and we can finish off early. Okay. So let me just slowly take this example. So if we have a sine, let's say 3x, and then cosine, or maybe sine, still sine 5x. Okay. We could write this in terms of half, and then cosine. Now this will be 3x minus 5x, right? And then minus cosine 3x plus 5x, okay? And then half, this will be cosine negative 2x, right? And then this will be cosine 8x, right? Now negative 2x, remember, as in our definitions, I think you also mentioned, yeah, it's the same thing as the positive one, because the cosine, if we think, I think it's better to explain with the quadrant. In the first quadrant and fourth quadrant, we could say, maybe let me show you this. Okay, maybe it's better to help you understand. So this is first, second, third, and fourth. Okay. Every time we move the axis, let's say we call this as a polar axis, although we are not yet to explain it. But let's just say this is the axis, the standard here. If you want to move like positive angle, we move here, right? But if we move here, we are getting a negative angle. So let me just write here. Then if we take this angle is, let's say it's negative pi over 4. Like, not negative, sorry, positive. It's pi over 4. Let's say pi over 4. What's happened here? If we move, so this is going to here. What happened if we move the same amount of? We measure the angle, the same amount of angle, but we move clockwise. So this will be the, let's say, the angle here, and we could call this angle is negative pi over 4. Or we could see this negative pi over 4 by looking at this. The whole is 2 pi, right? But this 2 pi, so we could see from this part, pi over 2, pi, 3 over 2 pi, and then plus this a little bit. So we could say this is 2 pi minus pi over 4, the same thing. But we could just say that, okay, this is negative pi over 4. Remember, within this fourth quadrant, what is the cosine? It's positive. So that means every time we have a cosine with negative, like negative blah 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 something inside, the result should be the same as the positive value. Okay? So we could say, okay, this is the same as the cosine 2x because of this phenomenon on this first and the fourth quadrant. Right? Okay. So we could write this as half cosine 2x and minus half cosine 8x. And that's it. Okay. Okay, now the next part is actually related to this. Okay? If we look at this u plus v, u minus v, u minus v, blah blah blah. Okay? If we could rewrite this u plus v into one single variable, okay? Maybe with another a or b or maybe x, y, to exchange in u plus v, we could rewrite a new formulation. Okay? A new formulation. So I hope you can retrace which part you need to, like, you prefer from getting to know. Like, for me, I think it's better from the sum, like cosine, like alpha plus beta, blah blah blah, sine alpha plus beta or alpha minus beta. I think that's easy to approach, and from there you can approach from to anywhere. I think it's better to project from this sum, I think. Okay, now from here, okay. So if we let me write here. If letting the, or maybe let u is x plus y over 2 and v is x minus y over 2. Now, before we take the sine u cosine v from here, we have half, or maybe let me just copy this. Okay. Now we can exchange all this u, v within new variables x and y. So u will be sine x plus y over 2. And then cosine x minus y over 2. And then half. And the u plus v, if you could see, it will be one part become x, one part become y. Right? You can see that when you plus these two, this y will cancel, right? So it's just x. So half x should be x. If you have u minus phi, you will cancel the x, and you will see the plus and minus become plus, so plus y. So we could see that this will become the sine x plus sine y. Or we could say that sine x plus sine y is twice of the value of sine x plus y over 2 cosine x minus y over 2. And the same way, we could exchange for the minus one. And the last one is going to have the negative part. Okay. Okay, perhaps one of the problem in basic math, especially for the analytic trigonometry, is to prove some identity. So proving identity. So identities can be in any forms, in any structure. What you have to learn is the basic ones, like the double angle, the Pythagorean identity, and so on and so forth. Now, to prove identity, we could also use the sum formula or the product formula for the trigonometry as well. So, for example, if this is like sine 3x minus sine x, okay, if we wanted to prove this, I think I also kind of showing you like what we have in the trigonometry. One of the problems is to prove the identity. Okay, so of course we could start from the left or we could start from the right. But from the right, I think we are missing like a lot of things. So we are not sure like sine over cos x and then what else. So probably we could start from here, and if you see that, it's obvious that it has 3x, x, it's sine, minus sine, cos, plus cosine. So it's supposed to be, we could maybe arrange within these terms, okay? So let's arrange all of that. And probably we could take this, or maybe let me rewrite again this part and arrange in the bottom part of the equations. So we could arrange this within the formulation that we just did. So 3x plus x over 2, and then sine 3x minus x over 2, divide with 2, cosine 3x plus x over 2, and then cosine 3x minus x over 2. So this will be, the whole thing will be 2x. This is x. This is 2x, this is x. So we have 2 cosine 2x sine x, and then divide by 2 cosine 2x, and then cosine x. And we see that we can cancel this 2, and it's simplified to be the tangent x. Okay, we are in the nearby the last section. So the whole thing here, we have all the identity. The next part we'll have solving some equations, okay? Solving some trigonometric equations. Okay? And we can have some couple problems after that. Yeah, and maybe if you have any questions regarding the previous chapters, you can also discuss with me. Any question on this? Okay. Okay. Sometimes silent means you understand everything or you confused of everything. Okay, but I think because engineering mostly, I think you guys are in engineering department, right? Because I have, I think last year, one student is not from engineering, so, but he has like really efforts, put up his like works, and yeah, he's from the foreign language, but he got to the class, but he got a good score, I think, for his background. So I think for engineering students, I believe it's really good if you have a good sense in logic, especially mathematics. By mathematics, I don't mean that you need to memorize everything, memorize any formula. No, I mean a good logic, okay? How to solve problem, how to logically, like step-by-step problem. You can take time to solve like layer by layer, but you know your objective. Okay? Sometimes you have a problem, but you cannot identify what kind of problem, and then you feel confused, and then you miss out. But of course, your exam, any exam you face in your college or maybe in your high school, they just exam like simulations, right? It's like a simulation. It's not really a problem. The problem is when you graduate, like maybe you work in some industry and you were asked by people, and you can solve that problem. That's really big problem. That's really big problem.
Because there's no answer.
Yeah, no answer. But now it's just like simulations. We already have like sets of models, right? What we learn here is all models. It's all models. Like okay, when we put here, okay, we got here, we got here. Like when you maybe some of you already, I think some of you already doing some coding. a little bit, right? A little bit coding. Like you can decide, okay, we can, like coding is mathematics, right? You put something, you make a model, you make a function, right? You make an algorithm. Like when you use your app, you take your time to think, okay, which one that maybe most people will appeal. Okay, maybe we take this color, maybe this price, and then okay, oh, high increase in market, okay, sales increase, you will be rich, blah blah blah, right? It's all like models. Okay? So if you can find this type of curiosity in your college life, I believe you will survive. You will survive. Okay? I believe you will survive. If you can find this type of curiosity, that I think everyone has a different type of like curiosity. Like, I think someone who invented like app, maybe he has a problem that maybe he feels like quote unquote maybe feels lazy to do something, and then okay, why we don't make the robot do things, blah blah blah, and then he make it like okay, solve problems, blah blah blah. Right? So I think if you can find this type of curiosity, like maybe when you learn like this math, all the things like numbers, and then you feel confused. But if you can find something that, when you think about it, you think more. Like, okay, I need to solve this problem. So why I cannot solve it? And then you find maybe some sparks in yourself, and then you feel that, oh, I can do it. And then you can follow you can like go through YouTube. And I think from the YouTube itself, you can like find everything, mostly in basic math, or in any math for high school or maybe for college. I think the internet has everything, so it actually depends on you. Okay, it was happened to me one time. I feel like maybe math is not my things when a long time ago, but then I feel that, oh, why this is so interesting, and I keep doing like, oh, I can solve this problem, blah blah blah. Okay, I know my math. Okay. In high school, my first exam in math, like the maximum, let's say 10, I got 3 in math. I got 3 in high school. I think the first year, and I was shocked because that teacher, she put some questions from the math Olympics. So it's so crazy back then. But yeah, like wow, and then I see like, oh, I see my friend, he got 9. Like, wow, and then why he can do that? But then, yeah, maybe at the second year or maybe third year, I can get my perfect 10. So I believe you can do it too. And I think you need to find your sparks. Okay? You need to find your sparks. Okay, this will be the last sections. Okay, this is you can say trigonometric equations. Okay. Okay, first thing, in trigonometry, we learn about angle, right? Radians, okay? We know the full circle is 2 pi. So every time we talk about sine or cosine, they will always have periods. They have periods every 2 pi, right? So if I write sine theta equal 1/2, okay, and I believe most of you are already familiar with the special formula for the special angle. If not, I suggest you to follow that. We have like 0, 30 degree, 45 degree, 60 degree, 90 degree, right? This is all the special angle formula. We have sine, cosine, and tangent for this formula. Okay, but I think you could just take your time to see the sine, okay, and then see the cosine, because sine and cosine, they are actually complementary. Okay. So if you see this going to be half, then perhaps your mind will tell you that, okay, maybe the theta will be 30. But remember, we are talking in the quadrants. Okay? Every time we talk in trigonometry, we talk in quadrants. We talk in periods. So the theta, this could be, let me write in radians, the pi over 6, 30 degree. Or we could also say that maybe it's 5 over 6 pi. Because in 5 over 6 pi, the sign is also positive. So maybe it has to. But remember, although we see that in full circle it has to, we cannot say that is there any interval for this? So we need to plus this with the period. Because we are not restricted the theta in the interval. Okay? We need to write completely that this will be having some additional periods. Let's say we say 2, let's say n or maybe k pi, and this also, because every 2 pi with some multiplications, maybe it has 3 circular, or maybe 4 times, maybe 5. Okay. At least they will have some additional periods. Okay. We need to write completely, unless they maybe provide you with some interval, and you can just follow that interval. Okay. Maybe if it's asking the interval is from 0 to pi over 2, and you can just answer, okay, pi over 6 is the answer. Okay. Maybe if you would like to know the angle, maybe this will be the angle. Just to show you how we could see the theta go from here and go from this x-axis to this 5 over 6 pi. It has the same value of half. Okay. Now another types of the equations. So first equations is you need to mention all possible answers. Okay, all possible quadrants. Okay. The second part is let me just write the example. So let me write example. 2 cosine squared theta minus 7 cosine theta plus 3. Let me write the theta like that to clarify. Okay, solve these equations. Okay, now we have this 2 cosine squared and minus 7 cosine theta plus 3. So yeah, but 3 is just a constant. But we could see that from this cosine, it's supposed to be, or it seems it's behaved like a quadratic equation. So we could imagine this as a quadratic equation, and we need to find the roots. It's as usual roots. So this is like quadratic type. We could imagine like cos theta is a, let's say, and then we could write 2a squared minus 7a plus 3. And then we could factorize this, we try factorize. If you feel still clunky on doing factorizations, you could follow my method. So 2a squared, it's from 2a multiplied by a, right? Or you could say a to 2a, same thing. And then the constant 3, we could write that from maybe 1 and 3. But if we write 1 and 3, the middle one has negative. So maybe negative and negative. To make it negative 3 by 2 is negative 6, negative 1 and a, so negative 7. So perhaps this is going to be negative. Okay. And then check with cross multiply. And if your result is the middle part of the quadratic equation, then that's your factors. That's your factorizations. Okay, so we could have from here that this will be 2a minus 1 and a minus 3. And we could write down that a is cosine theta. So 2 cosine theta is equal 1. Or cosine theta is equal 3. And this part, cosine theta is equal 3, is, I believe, it's impossible, right? So we could reject these solutions. So this is rejected. So we could focus on the cosine theta is equal 1 over 2. So cosine theta 1 over 2 is when theta is pi over 3, right? So we could write theta pi over 3. Remember to plus with the period. You can write period with k, with n, some books with n, some, I believe still they are the same. And also, this is also true for 2 pi minus pi over 3, where the cosine is positive, right? So 2 pi is 6 over 3. 6 over 3 minus 3 over 3 is, what is the, this is 5 over 3 pi, right? 6 minus 1, yeah, minus 1, 5, yeah. Plus 2k pi. This is, let me write, this is quadrant 1, this is quadrant 4. If you need to write k is any integer. Yeah, we need to make sure that k is integer. If it is decimal, we'll have a problem. Okay, still in the trigonometric equations, we have more examples. Let's say we have 1 plus sine theta equal to cosine squared theta. So solve these equations. Okay, maybe you could try yourself. Okay. You could try and okay, maybe let me write maybe 2 questions. So first is that, and the second one is cosine theta plus 1 equals sine theta. So solve this in interval from 0 to 2 pi. But 2 pi is open interval. Okay, let me give you some time, maybe 5 minutes to just to check, or maybe you want to discuss other problem as well. It's fine. Maybe as a reminder, don't forget to take the quiz. The quiz I put in the middle. If you maybe not really sure, have some problem, in technical problem, just let me know. Because suppose you just have one-time registration to the platform. So if you have any difficulty, let me know. Okay? Because some maybe if you have like technical problem with your connection or laptop, let me know.
I haven't seen the first one.
Okay. Yeah.
So this is
So you need square.
yeah, square both sides, and then yeah, some formulas. Also, yeah, maybe the format is a little bit different.
Yeah, but I understand. I understand. Yeah. I think that the second part, you have the interval, right? You can just follow the interval. Okay, so for the first one, I believe because we have sine on the left and we have cosine squared on the right, I think we can take these formulations and mix them into all with sine. All left hand side, right hand side, we have sine. So we could take this cosine squared and rewrite into 1 minus sine squared. Okay. And then we could rearrange our structure. So we are going to write 2 sine squared theta. We move to the left. And then plus sine theta plus 1 and then minus 2. So we have minus 1 at the end and then equal to 0. We could think this as a quadratic equation or a polynomial degree 2. We could take this with 2a squared plus a minus 1 if you want. Okay, and then we could say that we could factorize this becomes 2a minus 1 and a plus 1, right? Yeah. And then we could take this. So 2 sine theta is equal 1, or sine theta is 1 over 2. And the other part is sine theta is equal negative 1. So the theta, when it is sine theta is equal 1 over 2, this will getting the pi over 6, okay? And then the second quadrant, which is 5 over 6 pi. And then the other theta, which resulting negative 1, is 0 over 2 pi. Or we could write down the theta with its periods. So pi over 6 plus 2k pi, or we could also write the 5 over 6 pi plus 2k pi, and then 3 over 2 pi plus 2k pi. And this would be your answer. Okay.
It should be 3 over 2 pi, or it can be also a negative 1 over 2 pi.
Yeah, we can also write.
It's
Yeah.
the same, yeah?
Yeah, the same. It's just the minus of that. Yeah, but the same value.
Because k is an integer which can be I was told that you can just write.
Okay, and remember, whenever you have the angle, sometimes some of them are not really true. So we can check all of them into our equation. But I think for our case, I think all of them, okay, I think it's correct. But for the second one, you need to check, okay? Because I think one may be not correct, okay? So let's go to solving the second one. So if we look at the equations, we have cosine plus 1 and then equaling sine. Okay. To make this solvable, we need to make sure that we can transform the cosine or sine into another one, right? how we can make sure that we can transform both sides. We can square both of them. When we square, all of them, at least the cosine and sine, has a squared structure in which we could take the squared structure into Pythagorean identity. Either we could take the cos squared become 1 minus sine, or sine become 1 minus cos squared. Okay? So let's square both sides. So let's square and this will be cosine squared theta plus 2 cosine theta plus 1 equal sine squared theta. So I think it will be easier if we just rewrite this sine squared becomes cosine squared, and then we can combine with all of this and becoming a new quadratic type equation, right? So we could rewrite this and take the sine squared becomes 1 minus cosine squared, and then we could take the 2 cosine squared theta and then plus 2 cosine theta, and then the constant is 0. Yeah, the constant is 0. So it's going to be equal to 0. What's next? Okay. One mistake that maybe you make if you are not careful, do not cancel this. Do not cancel with divided by cosine, because in our case here we are having these equations equaling this to 0. So there might be some formulation inside that, okay, maybe we are going to have this is equal 0. If you cancel that, then we are going to eliminate the possibility of making this 0. Okay? So the best way to solve this is, as I mentioned, I think before in the polynomials and also in the domain, we can factor out the cosine. Okay? Just factor out. So 2 cosine theta is cosine theta plus 1. And now it's become clear. This left part can be component that makes this equation 0, or this inside the bracket that makes 0, which means the cosine theta may be a negative 1. It's also can be a possibility, right? So we can have two possibility that the 2 cosine theta, this will be 0, or cosine theta is equal negative 1. So when cosine theta is 0, then theta will be pi over 2 or 3 over 2 pi. And for negative 1, theta is pi. But we are going to check. We are going to check all this possible answer. Remember, our interval is just from 0 to 2 pi, but not including 2 pi. So we are going to check all these components. So check theta equal pi over 2. We could check let's say the first equations, the second equation, sorry. This cosine theta plus 1. Okay, so cosine theta plus 1 equal to sine theta. So let's say we take this cosine pi over 2 plus 1 equals sine pi over 2. I think it's correct, right? It's correct. Cosine pi over 2 is 0, plus 1, 1. So sine pi over 2 is equal 1, so it's correct. Okay, so it's good. No problem here. We take the 3 over 2 pi. So this is cos 3 over 2 pi plus 1 equals sine 3 over 2 pi. Now cos 3 over 2 pi is 0 plus 1, and sine 3 over 2 pi is minus 1. So it has contradictions. So we are not convincing yet that this is our solution, so we could reject this. So reject. And then lastly, we could take the theta equal pi. So cosine pi plus 1 equals sine pi. I believe this is also okay. This cos pi is -1 plus 1. Sine pi is 0. So it's true. It's possible. So the solution is just pi over 2 and pi. So solution on 0 to pi interval is theta equal pi over 2 and theta equal pi. So aside from the periods that you need to write, some equation that can be made as a quadratic type equations. Another equation for the trigonometric is when we have maybe multiple angles. Maybe it's not really a theta, maybe 2 theta, maybe 3 theta, but the solution still, the process still the same. For example, let me write here as example. You could write later for the previous one. Let me just write the example. 2 sine 3 theta minus 1 equals 0. So solve this. Solve all or find all solutions. Find all solutions. Or maybe find all solutions in the interval 0 to pi, because I think it will be very long. It's simply the same process as our initial example. So we could take this and equaling this exactly to 1 like that. And sine 3 theta is equal to 1 over 2. And 1 over 2, we already mentioned before. Okay, so we could write that 3 theta is probably pi over 6 and 5 over 6 pi. Okay, if we take for 0 to 2 pi. And we could write this 3 theta is pi over 6 plus 2 k pi, and 3 theta 5 over 6 pi plus 2 k pi. Or to be precise, if we would like to write the theta, we just divide by 3. So we could have pi over 18 plus 2k over 3 pi, and theta is 5 over 18 pi plus 2 over 3 k pi. And then to be precise, we could also write with certain integer k that the solutions will be pi over 18, 5 over 18 pi. So this is for k is 0. And we could take k equal 1. If we take k equal 1 is 12 plus 1, so 13 over 18 pi. And then 12 and 5 is 17 over 18. And then 25. And then 29. So this will be k equal 1, k equal 2. Okay, if you would like to write all the possible answer from 0 to pi interval. Okay, I think we could have. Okay, let me give you another example. Maybe just a couple examples, and then we can finish our course. Or maybe 3 examples, just to end our course. Okay, solve the trigonometric trig equations for sine theta cosine theta plus 2 sine theta minus 2 cosine theta minus 1. Okay. Oh, this is interval in, to make it easy, maybe 0 to 2 pi, like that. So that you can mention.
Because of one. If it wasn't one, I would just divide it. Also.
Okay.
You can take the one out.
Maybe second question, let me write here. Solve you don't need to solve the second one, this is the first one. But if you have finished the first one, you can go to the second one. The second one is kind of a tricky subject. If you write all the notes, you will see somewhere in your notes this equation. Maybe you check your notes. But yeah, let's say we are solving the first one. Yeah, we write some cubes in early class today. Not early class. Yeah, maybe early, but not that early. Yeah, any idea? Solve that? Almost. Yeah, the key is to factor this out. Yeah. Okay, I think probably. Okay, so if we take a look, okay. If we take a look this 4 sine theta cosine theta, if we take this as 4, let's say sine theta is A and cosine theta is B. Okay, let's say we have this. It's the same thing as if we take this 2A, we factor, basically, we could think that if A is equal B, if A is equal B, it becomes a square, right? And this is become it's subtraction between these two multiplications. And this is also squared. So if something has like -1 or +1, and when we multiply, it will become -1. So we could have some factors here if you think through this way. So let's say this is 2b. Okay, we multiply. Okay, we got that. And I think to make this negative, we could multiply with -1, right? And +1 for the 2a. So we could have (2a) minus 1 and then +1. Right? It's a little bit tricky, but we can factorize. We can factorize this too. We could imagine that, well, we could take a, b for sine and cosine, and then we could have this as our factorizations. And you could check one by one if you would like. 2a, 2b, 4ab, 2a, 1, okay, -1, 2b, and -1 plus 1 is equal to 1. Okay? So yeah, factorization is like playing like a puzzle games, like, but it's actually quite fun if you like see the pattern and oh, we could do this, we could do that. So from here we could take this equaling to 0, and then we could take this and then make a statement for sine theta and also for cosine theta. Oh, it's negative. Sorry. It's cosine theta is negative. So theta is pi over 6, 5 over 6 pi. And this will be, for the negative, for cosine, will be in the third quadrant and the second quadrant. So second quadrant, 3 over 4 pi and 7 over 4 pi. Hey, why 7 over 4? Sorry. This was supposed to be 2 over 3. It's 1 over 3, right? Yeah. And 4 over 3 for the third quadrant. Okay. Now, if you would like to solve this, remember that I wrote cosine 3x. I wrote the cosine 3x is equal 4 cosine cube x minus 3 cosine x. If we multiply this by 2, you can check your notes if you take notes before. This is 8 cos cube x negative sine cosine x. So we could write down 2 cosine 3x plus 1 is equal to 0. So we could write cosine 3x is negative half, and we can solve that. So x will be from pi over 3, so pi over 3, 4 over 9 pi, 8 over 9 pi, 10 over 9 pi, 14 over 9 pi, and 16 over 9 pi. Well, this is too. The actual question is not only this, but the previous question is related to the cosine 3x to prove this identity, and when it's proven, you solve this, and then you get the result. That's the original question. I just take parts and just showing the equations. Okay. Okay, I think I will just finish up until here. Okay, just finish off until here. I have a feedback questions as usual. Okay. Just to make sure that you just like take sometimes to work some equations, and we can finish off our course. Okay. If you would like to take notes, so you could take notes if you want. But the second question is too crazy. Okay, I think we can start the feedback. Do you still take notes or finish? Okay, I think finish. Yeah, I put another. Actually, it has like 5 or 6, but I just put 2. Usually, it's just one, like the love or heart like button. Do you have any course tomorrow morning? No?
I have course in English. Yeah.
9 or 10? 10.
But actually, I like our English.
Okay, we could start. Wait. We could start. Okay, if you maybe still not joining, you can join through the menti.com and use the code 51981441. You could write your student ID so that I can register your score into the system, at least for additional points. Okay. Okay, let's start. Okay, let's start the countdown. 3, 2, 1. I hope the time is sufficient. You could check your notes. Okay, you could check your notes to make sure you understand. The key is A is obtuse, B is acute. Okay. And then you can check your notes on sign A plus B. Okay. Yeah, you could check your notes. The sound. Yeah, hope time is okay. The calculation, I think, not really that complicated. But to remember, obtuse and acute will determine the quadrants. 1, 2, 3, 4, right? So if we know, I think for acute, no problem, right? No problem for acute. The problem is for the obtuse, so for the A. So maybe the other, so for A, maybe the other part will be having a negative sign, right? Or no? Yeah, the denominator always 65 because you can see the 13 and 5, so whatever we have, the combination is just 65. You could write the triangle if you want to take the Pythagorean to make sure that we all know. I think like triangle 4, 5, 3 should be familiar with. If not, then maybe triangle, maybe we'll have it. So for A, 12, 13, and 5, right? 6, 4, yeah, 5. Remember the angle it has obtuse and acute. It's B. Because A is obtuse, sine is positive, so the cosine should be negative. Okay? Who is Nicolaus? Who is Nicolaus? Who is Nicolaus? Okay. Okay, either way. Let's go for the next round. Okay, let's start. 3, 2, 1. So the question is the tangent and then inside bracket tangent inverse 3 minus tangent inverse 2. Or you can write r tangent 3 minus r tangent 2. So compute this and giving the final answer as exact fractions, like 1 over 4, maybe 1 over something, or maybe 3 over 5, or something like that.
I think we're not supposed to count it with the further it's this. Yeah. Or
Well, you could try it both way and then to convince.
always try it this way. So I tried this. I can see the clients right now. Count it.
Yeah. You could confirm.
Basic math can we use for
Generally no, but we can see. But I think for quiz, it's still okay. But that means that I will prepare something that you can calculate. Well, at least you could use calculator just for confirming that the process you need to still to run. But at least you know how to get your objective, right? Okay, the key, if you have inverse, that means this is angle, right? You could write as A and B. Can you rewrite something with that tangent A minus B in identity? I think if you took notes, or maybe if you look up your websites, identity for tangent, or identity for tangent A minus B. Or you could maybe write sine A minus B over cosine A minus B. Yeah, that's also true. Okay, I explain. Who will give the correct answer? And remember, if you have a function and you put the inverse inside that function, it's become the x, right? If you have f inverse, you put this f inverse inside the function f, inside f, f inverse of x is equal to x, right? So actually, with some sort of like a little bit training, you can solve something like this.
I cannot remember all of these formulas.
Yeah, but you need some time. Okay. Good job. 1 over 7. Okay. That's Jack. Who Okay, I think what's a lot. Okay. All right. The last one. Okay. Last one. I forgot to mention the interval, but yeah, I think you could choose from the option. We just discuss about this. I think it should be obvious. And sometimes in multiple choice you can check your options as well. So next week we will just take some. I will provide this video for you. And week after that, still video, and perhaps first week December we are going to have offline again classes, and that will be the groupings. The groupings that I mentioned early. Okay. So you will have some groups discussion, and perhaps the first discussion for maybe topic selection. I will give you more details on that maybe on later additional videos. If the number is not too complicated, I think you can get through the first.
Like when I split it's not the fastest available. Hey, right.
I'm just playing with them. Okay, good.
Yeah. Oh, I think you start, okay.
Okay, congratulations. Okay, last one, just write your ID. If you have any feedbacks, anything, okay. I know our class is like really late at night, so it's supposed to be sleepy.